Okay, so how does oxygen get transported? How is it carried? Is what we need to look at. Okay, so if we look at blood, and this is a review. Let's review what blood is. So if we look at blood, and we look at a centrifuged test tube of blood, you'll find that 44% of that is red blood cells. Jeez, can't get my thing to work. Okay. About 1% is the buffy coat, which is white blood cells. White blood cells, platelets, whatever. And then about 55% is plasma. So if I have make a red blood cell here. So I have a red blood cell, and we'll put the red blood cell in a big old capillary. So you got your red blood cell here, and it's going to float around. It's floating in plasma. All right, so most of the red blood cells, or excuse me, oxygen is carried on each one of these red blood cells. So in fact, about 98%, so 98% of oxygen is carried in the red blood cells. Okay, so that means only 2% is in the plasma, is dissolved in the plasma. So this oxygen rides through the capillaries to the tissues inside these red blood cells. And it does so on a thing called hemoglobin. And I think we've looked at hemoglobin before, but hemoglobin is a quaternary protein. So it's 4 subunits of proteins, or amino acids basically, that are linked together. And inside each of these is iron, a molecule of iron. And iron loves oxygen. It sticks to it. Okay, oxygen will stick to the iron. So there are about 250 million hemoglobin in one red blood cell. And each of those hemoglobin carries 4 oxygen molecules. So one red blood cell can carry 1 billion oxygen molecules. Okay, so the red blood cell is the preferred method for an oxygen to travel within the to travel in the blood. Okay, so if we have, see if we can make the thing here. So if we have our little trachea here and whatever, and on the trachea is an alveolus, okay? We know that inside the alveoli, the partial pressure of oxygen after a breath is 100 millimeters of mercury. Okay, so we know this. And the capillaries that are around the alveoli are bringing blood back that's deoxygenated. And when it does that, the PO2 in here is going to be 40 millimeters of mercury. The oxygen, of course, will hop along in here going down its partial pressure gradient, and it will go into the plasma, will jump in there, and almost immediately it will hop into the blood cell onto the hemoglobin. So we'll put this as a hemoglobin, and there's going to be 4 of those that go in here. So it's going to come in here, it's going to bring 3 friends and hop onto a hemoglobin there. Now, as the oxygen goes into the plasma, the partial pressure will increase, right? Because it's moving down its concentration gradient from high to low until it gets equal. So this should increase. Thing is once this oxygen jumps into the blood cell and gets on a hemoglobin, it becomes something else. It becomes something called oxyhemoglobin, which is a different molecule. So this number remains the same. It does not increase because this oxygen came in here. It increased for a second, but then it jumped in here, became oxyhemoglobin, and now we're back to 40. So now more oxygen can come over and jump into the blood cell. Okay, so basically this will occur until the seats are full. Just putting O's, but okay, until the seats are full. Sorry about that. And once the seats are full, then the oxygen will stay in the plasma. And when it stays in the plasma, then it will go up to 100 millimeters of mercury. So 2% of the oxygen will travel in the plasma. And that's how it gets in there, or that's how it stays in the plasma. Okay, what else? Okay, so again, depending on the gradient here is when we, inhale this is our alveoli. When we inhale the air into the lung, and the PO2 is 100 millimeters per mercury, and then it's going to diffuse over to the deoxygenated blood that's coming back from the tissues. And this is what happens. As it comes in, it loads onto hemoglobin. So once it gets to full, so what we call saturated, once it's saturated and the PO2 is now 100 millimeters per mercury in the plasma, then the hemoglobin, the blood cells with, or the red blood cells with the hemoglobin are said to be 98% saturated. Okay. All right. And so once it gets to that 98% saturated, that's when it goes off. It's oxygenated blood now to go off back to the tissues. What else? Okay. So so in the next video, we're going to talk specifically about what that means, what it means to be saturated, how it goes up and down, and how the oxygen, once it gets to tissues, what makes it jump off and go follow its concentration gradient, or excuse me, partial pressure gradient, and go into the tissues.